and then this is R for the other atom. So A equal to 2R for simple cubic. However, for BCC and FGC, A not equal to 2R. Why? Because this is A and this is R. And this is also R, and there's some empty space here. There's some empty space here. So R plus this empty space, then only equal to A. Okay, so A equal to 2R only applicable to the cubic and not applicable to the face center cubic and body center cubic. Okay, I hope it's clear. Therefore, but because now we are working on the simple cubic, we have to find the packing fraction. So basically, the packing fraction equal to volume of atom over volume of unit cell. So for volume of atom, very simple, 4/3 pi r power of 3. Then volume of unit cell is a power of 3, right? And then now we know that A equal to 2R. Okay, so equal to 4/3 pi r power 3 over 2r power of 3. This one. Okay, then you solve it, you get pi over 6. Then you get the percentage is 52%. That means the void fraction in the primitive cell is 48%, and then 52% is occupied by atom. So you can see from this picture. For this picture, 52% is occupied by the atom, and then 48% are empty. Okay, you can imagine, right, that this part is empty. This part is empty. So based on the calculation, the packing fraction for the simple cubic is 52%. So that means that 52% are occupied by the atom, and then 48% are empty. So simple cubic is very easy. So now we want to proceed to the body center cubic. In body center cubic, one atom is present at each corner and contribute 1/8 of its volume to the unit cell, and one is present at the center, and therefore it contributes 100%, right? Just now I already mentioned corner one, this one, all the white atom, 1/8 times 1 equal to 1, and then the center one is contribute 100% to this unit cell, so plus 1 equal to 2. So now you have to find the packing fraction. The definition for packing fraction equal to volume of atom over volume of unit cell. So now we have two atoms. So we have 2 times 4/3 pi r power 3 per unit cell. And then the volume is also a power of 3. Okay. So you have to find this one. But previously in the simple cubic, A equal to 2R. But for this body center cubic, A not equal to 2R. You want to find the relationship between A and R. You want to find the relationship between A and R. Then how do we find the relationship between A and R? So in order to find the relationship between A and R, you need to find the length for this one. Okay, what is the length for from this point to this point? Because from this point to this point, it has 1R, 2R, 3R, 4R. Can you imagine that? From this point to this point equal to 4R. Half of this atom, 2R for this atom, and then half for this atom. Okay, so R, 2R, R. From this point to this point. Okay, then next, how do we find the length for this one? So this is 4R. 4R. We know this is A. We know this is A. And then we know this is A, right? So we're able to find this one, right? This is A, this is A. So this one is A squared plus A squared square of A, right? And then this is A. So there's no difficulty to find this one. So this is A squared plus this one square of it, then you get this one. I repeat again. Okay, you know that this is A, this is A, right? Then this is the A squared plus A squared square of it, this one. Or I write as X. This is X, okay? And then we know this is also A. So this is X, this is A. So you want to find this distance between this point and this point, then you get X squared plus A squared square of A, right? And equal to 4R. Then now you know the relationship between R and A, okay? Which is equal to this one. Square of 3 times A. So after you solve it, you get 0.68. After you solve it, you get 0.68. It means that in the above unit cell, in the body center cubic unit cell, 68% is occupied and 32% is empty. Okay, then for face center cubic, the percentage is 74%. So let's say I ask you to find the packing fraction for FCC. How to find it? The packing fraction equal to volume of atom over volume of unit cell. Okay, the volume of atom is, there are 4 atoms, right? 1/2 times 6 equal to 3, the face centered one, and then 1/8 times 8 equal to 1, the corner one. So there are 4. 4 times 4/3 pi r power of 3 over the volume A power of 3. Okay, we want to find the relationship between A and R. Okay, so that we can solve this equation. So how to solve this? It's very simple. We cannot say that this is A and then A equal to 2R because they got empty here. However, we can make use of this diagonal. Okay, you can see that there's no empty here, right? So this is R, this is 2R, this is R. So I can say that this length equal to 4R. Okay, diagonal equal to 4R. So this is A, this is A. Then here is square root of 2A. So square root of 2A equal to 4R. Right. So A equal to 4R over square root of 2. Then you just substitute this into here. Okay, you just substitute into here. Then now you only have 1R unknown. Then you can solve it. Then you get the FGC has 74% of the occupied volume and only 26% of empty space. Okay, so this is the highest that we can get in the solid state in all type of the arrangement. 74% is the highest one, and therefore we call it the closed back structure. There are 2 types of closed back structure: face center cubic and then hexagonal closed back structure. And I will discuss this face center cubic and hexagonal closed back in I think in next 2 chapters, if not mistaken. Okay, so that's all for chapter 2, and I hope that you have learned some new knowledge from this chapter. Thank you.